All right. Let's talk about a nice topic today. This is actually, let me start with the homework. So we've covered just about everything that we need for learning objectives 1 and 2. There's just one little caveat in objective 2. This little note that I've completely ignored until now, but we're going to address this full on in today's lecture. It's a little note of when you read your HTTP request from the TCP socket, you might not get the whole request all at once, and specifically Chrome, when it sends a file in an HTTP request, it'll send just the headers, and then there will be a delay, and then it'll send the actual file, the contents of the entire body of the request, which is a little bit of a problem that we have to handle. And in general, if we send very large images, we can't just read that whole image all at once from the TCP socket. It's not going to work for us. We need to read it in parts because it takes a while to send that file, and we need to be able to handle that feature, I guess. Also the /r/ends. I don't know if I'll have time to demo that today. That might be on Friday. But actually, let me just cover it right now so I can say I covered it. The bytes of the image, it's just any bytes encoded using whatever JPEG, PNG, whatever encoding we're using. /r/n is a valid encoding, or is a valid byte sequence. /r/n, it's just 2 bytes next to each other. In ASCII and in UTF-8, because ASCII's a subset of it, that's those mean /r/n. The bytes that represent those values are /n/n when decoding as UTF-8. But those same bytes can appear in images. It's legal bytes. It's a legal 2-byte sequence. There's no magic to it. It just has special meaning in HTTP when interpreting those bytes as UTF-8 text, specifically ASCII text if it's in the headers. So these byte sequences can appear in your images, and they will appear in the images that we're going to test with when we're testing application objective 1. So if when you get a request, one of the first things, or ever, one of the things you do is go .split /r/n, or even .split /r/n/r/n to separate the headers from the body. What you've done is just chopped your image in half. And when you read the bytes of your image, you're only getting some of the bytes of your image. You're going to have a corrupted file, and it's going to drive you, well, actually, it won't drive you nuts. Everything's going to look like it works fine, unless, depending on your testing images, either you're going to find this bug or not. And then when you submit to Autolab, we're going to say your image uploads were completely broken for application objective 1, and then you're going to come to office hours, and we'll talk about it then. If you don't listen to it now. Don't split on these characters. You need to find the first instance, ideally, of these, and then separate the values. So if you're separating the headers of your HTTP request with the body of your HTTP request, you look for the first instance of this byte sequence. You look for the first instance, and then everything before that's your headers, everything after that's the body. You don't do .split, and then splits of 0 is my headers, splits of 1 is at least the first part of my body. You know it's going to get chopped up because you have your multi-part stuff. So you know that sequence is going to appear in those, and students do some wacky stuff to try to get the values because you just chopped up the headers and the body of each part, and then they try to piece all that information back together. But when they get to the image, they chop their image in half, and they only get half of the bytes. But they usually don't find that in testing. They find it in grading, and then they don't get the grade they expect. So make sure you're handling these. For testing, we have several images that just happen to have that byte sequence that we test with. And also, if you want to test and not just look all over for an image that has this, you can, what I'd recommend is go into a hex editor and add those characters into your image, and then use that as your test image. So you can just manually put those bytes into your image, replace a few bytes with these bytes, and then test. So if I don't get to talking about this in more depth than that, I at least got that out there. So we're going to cover everything we need for that last caveat in Learning Objective 2, everything we need for Application Objective 1, assuming what I just said about these /r/n's is good, was good enough. And for Application Objective 2, there's nothing new that I'm going to cover in lecture. I have a lecture on these cross-site request forgery tokens to talk about the theory behind it. But you have all the mechanics, all the coding knowledge that you need to implement that now. But we will cover the topic. And then Application Objective 3 is, I believe I moved this to next Wednesday. Oh, no, I did leave it Friday. Unless I need to refresh. On Friday, we'll cover that. So cross-site request forgery next Monday for Application Objective 2 theory, and then Application Objective 3 is next Friday. I might end up swapping these still, because I want to get Ajax and polling earlier, so you have more time to work on that. Instead of a full week, I'd like to give you a week and a half or so. So any questions where we're at with the homework? And just to emphasize that after today's lecture, both learning objectives are completely on the table. I'll be done talking about those. There won't be anything else in lecture that can help you with those. That's all in your hands after today's lecture. So any questions about this? Or about anything at this point? What is... I have to check this real quick. Like, what the hell? Just Docker. 9.74 gigs. That's why my fan's been running all day. And Python. No, I do have some Python running. I'm not going to hunt it down, but I must have a server running as well. Okay, so let's talk about buffers. This is something you will absolutely 100% need for Application Objective 1. And for testing in Chrome, to get it your code working in Chrome, you'll need for Learning Objective 2. Because just Chrome likes to do things different. In Homework 1, I use split on /r/n to get the header, but for Homework 2, do I change it to /r/n/r/n? No, you didn't listen. God. No, you don't use split. For Homework 1, it was all fine. Like, I didn't throw anything at you like that on Homework 1 because you're just getting used to HTTP. So there wasn't anything like this. On Homework 2, you can't split on /r/n or /r/n/r/n. You can't split on either of those because your image might contain that byte sequence, and you're going to chop your image in half with the split method. So you can't use split. You need to use something... honestly, what most students do, you can call a split with a second argument, and that'll be the maximum number of splits that you'll get. That's the cleanest way to solve this. Or you can find that byte sequence, get the index of it, and then use your, I always forget what it's called, but your splicing, your array splicing operators in Python with the colon in your brackets. Use that to split your values more manually. That's the method I prefer because I just have more control over everything. But just making sure that you don't split the bytes of your image if your image contains /r/n/r/n, which it might, and it will when we test. We will be testing for that. And if you're vulnerable to that, if you're chopping up your images and users who happen to have that byte sequence in their image just can't use your app, that's going to be a 1 on the objective, and you won't get that application objective. We are testing for this, and you do have to address that. But yeah, the key word was split. You can't use split anymore. You can rebuild it back after. Yeah, I mean, yes, you can use split as long as you don't use those results to get the bytes of your image. You can re-splice together your image. You can check, do I have the number of splits that I expect? Which is, by the way, one way that you can check if you have that error. When you split, there's going to be a certain number of things that you expect. Unless you're splitting headers, you don't know how many headers there are going to be. But when you're splitting on CRLF, you're going to be expecting a certain number of values. And if you have more than that, you destroyed your image. You can rebuild it. I mean, that's perfectly valid, but that's way more code than you need to write. Just don't split it to begin with. Yes. Yeah, you need to be able to handle buffering in any browser. Chrome will, and I'll demo that. Chrome often only sends the headers pretty consistently, actually. Once you start uploading images in your form, Chrome is only going to send the headers, and then you have to go back to the TCP socket and get the image. It's going to be crucial to finishing learning objective 2 in Chrome. It'll work in other browsers. Chrome's the only one I've seen that behavior in. Surprisingly, other Chromium browsers don't even do that, which we'll get to the demos and I'll show y'all. We don't have too many slides today. Today's a lot of demo day, like half the day is demos. So we do file uploads now. Let's get some context to what we're talking about here. We do file uploads, right? We have the bytes of the file. The bytes are removed in this example because it would take up many slides, even with just 746 bytes here. It's a lot of bytes. So we're going to get this request. We've talked about how to parse this. I'm done talking about how to parse multi-part forms. If you have questions, I'll be happy to answer them. I just don't have anything else to say about them. So we know how to parse this. We're going to get the bytes of our file. And we're going to use something like this. If you're using JavaScript, you have some code that looks like this. If you're using Python, you have code that looks like this. And I got the dot strip in there. I got this out of most of my code. Speaking of, I don't want to rant again this lecture, but I used to have this dot strip in my code just because, honestly, there's some documentation that has dot strip, and I took it from that. And then and I wanted to trim the white space on my string, so I was fine with that. But once you move to parsing bytes, you can't call dot strip on it anymore. And students were getting errors because they were just blindly copying the code that I gave. So I finally got rid of all those up until now. But similar rant to last time of students will just blindly copy my code regardless of whether it makes sense or not. My examples are not made to be the homework solutions. Can't stress that enough. I hate seeing my code in office hours completely used out of context, and then why doesn't it work? So you're going to do something like this. This is going to read bytes from the TCP socket. What is the int parameter to receive? The docs use 1024. I'm glad you asked. I want to talk all about it, like all day. What is this number? So this is the maximum number of bytes that you're going to read from the TCP socket. So you're going to have some code like this. And just a reminder on how TCP works is TCP does create a persistent connection. Now, we haven't been using it as a persistent connection in Homework 1, but in Homework 2, we have to start treating it for what it is, which is a persistent connection. You do the three-way handshake that creates a connection, and then you can send bytes in both directions. You can send bytes to the client can send bytes to you, and you send bytes over this connection until one of you closes the connection. Until one side closes the connection, you have a stream of data. A stream of data. With GET requests in Homework 1, we didn't care about that. We just said, if there's data to be read, it's a whole GET request. It's an entire HTTP request. Give me that thing. Let me send something back, and then close the connection. And by the way, in Python, at least once you hit the end of the handle method, the library will close the connection. So as soon as that method exits, it closes the connection. So when you have your if block, you get the request, you handle it, you send all, and then it just naturally reaches the end of your method. That will close the TCP connection whenever you hit the end of that method. So that would be you closing the connection, then no more data can get sent. With GET requests, we read once, we send once, and that's it. Request, response, done. That's all we need for HTTP. But what happens when we have a large image that's being uploaded and we receive our data with something like this? Your TCP library I didn't put it on the slide. I think it's on a later slide, but I'm saying it now. Your TCP library is going to read up to a certain number of bytes. And here's where I'm getting back around to answering your question. Is going to read up to a certain number of bytes. That number is whatever you put right here in Python. Whatever number you specify, you're saying, if I open up this stream, the client can just send me bytes whenever it wants. Whenever they want to send me data, they're just going to send me bytes. And what the receive method says is, if there are bytes to be read, read up to 2048 bytes of that data. In the documentation, it's 1024. In my slides, I changed it to 2048 because there have been cases where a browser will have a lot of headers, and it'll send more than 1024. It'll send more than 1024 bytes. I had a few students run into that issue, so all my slides I updated to 2048 because that guarantees that a GET request is going to be read in one go. I shouldn't say guarantees, but I haven't seen that not be enough. So you're going to read at most this many bytes. So receive, hey, TCP socket, if there are bytes to be read, give me at most 2048 bytes of data. And then it returns those bytes into whatever variable you have in your code, and then you parse that as a request, and you handle it however your server's supposed to handle it. The hi, hello, index.html, style.cse, et cetera, images, flamingos, eagles. You do whatever you're doing with it, with that request. And you send data back over the server. So this is up to 2048. If there's 3,000 bytes sitting on the socket ready to be read, it'll give you 2048 of those bytes, and then to get the rest of the bytes, you have to read from the socket again. You have to go back to the socket and say, hey, if there's data to be read, give me at most 2048 of them. And then you'll get more of the data that's sitting there waiting. So if this is the image that's being sent, if it's 1.8 megs of data, we got over 1 million bytes sitting here waiting to be read, and we're going to say, give me 2048 of them. Give me 2048 of them. And you have to keep reading until you read all of the data. Yep.
Do we have to worry about
the size of the size of this array?
Yeah, receive data.
No. Yeah, so if you keep appending to that, that's perfectly fine. That can be megabytes. And we won't test in the gigabyte range because we'll start like maxing out RAM. So we don't want to do that. So we're going to read 2048 bytes at a time. And this is up to, I can't stress that enough, this is up to 2048. Even if you're expecting more than 2048 bytes, you might not get even 2048. This is the case with Google, with Chrome. When it sends, when you upload a form, it's going to send the headers. The headers might be less than 2048 bytes, so there's no simple way like if the size of the data read was 2048, go back and read again. Students like to do all kinds of little tricks like that. I've seen all of the shortcuts that y'all try. They don't work, and I see them because they're in office hours, because their code doesn't work. Don't use the shortcuts. Just implement this the right way, please. But you read the bytes. It's not 2048, but it's all the headers up until the blank line. And then it will delay a little bit and then send the multi-form part, the body of the request. So you read once, you don't get everything. It looks like a GET request, and you're missing the body, and then you try to parse it and send things, and everything breaks. You'll have to read again a second time if you didn't get any bytes of the body. So if the body's missing on a post request, hit up your TCP stream again and say, hey, give me the rest of the stuff, to be able to get that information, and then you can parse it and do your things with it. If it's this big, you got to go back to this socket many times and keep calling receive. Same thing with, I won't talk about, I might get to the demo in JavaScript. I might actually demo JavaScript today. But if you are using JavaScript, this method is called, this callback is called whenever there's data to be read on any socket, which for our purposes in homework 2, there's only going to be, you only have to handle one upload simultaneously, so it'll be just the socket. But this will be called with the data whenever there's data to be read. So if this is called multiple times, On the second call, it might be the same request as the previous one. It just might be more data on the same request. So you have to watch out for that. If you expect more data on the same request, don't treat the next call of this method, this function, as a new HTTP request. It is a continuation of the previous request if you haven't read all the bytes yet. And the buffer sizes get pretty big in JavaScript. The default is up to, I think, 64K or 128K, I forget. It's pretty big though, far more than 2K. So we use buffers. So there's going to be a fixed size, not fixed size, there's going to be a cap to the amount of bytes you can read in one go. As I just mentioned in JavaScript, you don't have any control over that cap. In Python, you do. You actually give it as an int. You say, this is the cap. Give me at most this many bytes that are waiting to be read. So you're going to have buffers, regardless of how much control you have over the buffer or not. You're going to have some sort of buffer in your data. So you're going to get some bytes. When you have this large image that's being uploaded, and you read from the socket, you'll get some of the bytes. So if the user's sending a lot of data, sending a large image in our case, you're going to have to read from that socket multiple times as the pieces come in. And there could be a lot of reasons for this aside from just large uploads. We could have a lot of different things happening. Maybe somebody has a lag spike or something in their connection, and the next send is delayed. Those are the things that really get the students who are trying to cheese things is what if something else happens? You get a delay where there's still data to be read, but you get a little hiccup where you read 500 bytes in a call, and you have if I didn't read 2048, then I'm at the end. Or students like to do the math, like however many bytes I'm expecting, just set the receive to read that many bytes, and then just read them all. That doesn't work either, because you'll get what's ever ready. What if you're sending a really large file? All the bytes aren't going to be ready the first time you go to the socket, to the TCP stream. So where's the actual question? JavaScript boo. Yeah, why not just read? Oh yeah, and I just answered that question incidentally. Why not read all the bytes at once? Why limit to 2048? Because they might not all be ready. It might take a while to read a large file and send it, megabytes here, but what if it's gigabytes? What if it's an MP4 that you're downloading or uploading? All that data won't be ready all in one go. We got a buffer. Buffer's just, and this comes up everywhere in computer science and programming. Like, you got to get used to buffering. This idea, this concept of buffering. So each fetch from the buffer contain a header, or can we assume the next bytes of the fetch will just be image bytes? Just image bytes. You won't get more headers. It might not necessarily be image bytes. You might be somewhere in the middle of one of the multi-parts of like the comment or something. But it will be, when you read multiple times, it's going to be like it's one giant HTTP request, because it is, but you have to read multiple times and stitch it together. So you have to keep reading before you can parse the entire request. Oh, that's a lot of text. All uploaded comments must be stored in your database. Yeah. You must use the database. I feel like this is cut and paste from my thing. What does this mean for LO1? You have to use your database? I'm not sure what you're asking about. You just pasted a big chunk from my homework doc and said, what does this mean? You have to use a database is what that paragraph means. I didn't teach databases for nothing. It was kind of a mistake, but you should have been forced to use databases in homework 1. You only had to if you did the last two application objectives. So I'm making sure you get practice with databases on homework 2, right from the learning objectives. Yeah, more of an office hour question. At most, I think I've said that enough this lecture. For your GET requests, it was always safe to assume, I didn't mention buffering for homework 1, so it's safe to assume you read once, you get the whole request, and that's it. For post requests, especially for image uploads, not the case anymore. So how do we handle this? What do? We know we're going to call go to the TCP socket and ask for bytes multiple times, but how do we actually do this? What do we do? So we're going to read once, and it will still be safe to assume in this course only, that you read from the TCP socket one time, that you'll get all of the headers. That's not generally true, and someday I'll update the homeworks to make you actually do this, but it's not generally true. You should keep reading from the TCP socket until you see /r/n/r/n to say the headers are done, you have all the headers. This is why when you're forgetting that on your 301 responses, some browsers, I think Firefox hangs, but Chrome is like, I got you. Firefox will hang because it's looking for that character, that byte sequence, and if it doesn't see it, it's still saying, well, there's more headers to be read. You should be doing the same thing on your server side. I don't have a good way to test for that, actually, because you usually just get away with not doing that. So you should be looking for the same thing on your server side, but for this course, it's going to be safe to assume that the first time you go to your TCP socket and say, give me some data, give me 2048 bytes, that you're going to get all of the headers and possibly some of the body. But you can safely, bless you, but you can safely say you're getting all of the headers. So you read one time, you parse all your headers. Hopefully you all have general parser heading code by now, I hope. I know most of you don't, but I can live in delusion, can't I? That you all wrote a general header parsing method that takes all your headers and puts them in a big key value store, so it's easy to look up your headers, because we're going to be reading headers all semester. You write that code once for homework 1, you're going to get a lot of mileage out of it when you have to read all these headers throughout the semester. So you parse your headers, find the content length. You do actually have to read that thing. It's not something I just talked about for fun. We're going to read the content length header, parse that as an int, and then keep reading from the socket until we read that many bytes of the body of the request. So we read once, parse the headers, get the content length. We'll check everything after that first blank line, that first CRLF. Those are the bytes of the body, which there might be something there. In the case of Chrome, there might not be. In the case of Chrome, where you're uploading just a comment with no image, you might get the entire body. There's a lot of different scenarios. But you've got to read the content length, check how many bytes you've read already from the body, and then keep calling receive until you've read content length number of bytes in the body. Remember, content length is the number of bytes in the body only. It does not include the bytes in the header. So be careful when you're writing your code. Make sure you're reading the bytes of the body, and keep reading from the body until you have a byte array of size equal to the content length. Once you have that, then you're done reading that request, and then you can start parsing the body of that request. You've already parsed the headers. You can already parse the request line at this point, but you can't parse the body, all your multi-part stuff. You can't parse that until you're done buffering. So this is commonly a while loop. Well, I haven't read the number of, my byte array storing all the bytes from my body, where I'm appending all the bytes from the body, well, that length is less than content length. Read again. Just keep going through, read again, read again, read again. Call receive, 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 until you have content length number of bytes. That's the process. That's how we build robust code. Don't say content length minus the number of bytes I've already read and receive that number. Don't do that. Don't just receive a trillion and just say, well, that'll read everything. These don't work. These solutions all have issues. That's why I always see them in office hours. Don't do any of that stuff. I'm still going to see it in office hours, I know, but it doesn't work. It works sometimes, but sometimes it doesn't, and it's just really buggy code because it doesn't work, because it's wrong. All right, any questions so far? With the database talk, if you're using a database the way I showed in class, you don't have to worry about that paragraph. That paragraph is just there for people who like to cheese the database stuff. They'll set up their Docker Compose to run a separate database, but then in their code they'll use SQLite and just use a local database inside their container. But that doesn't give you practice building a system of two containers that are communicating to each other. Basically building the start of like a microservice. We have two different, not really microservice, but we have two different services communicating with each other to be able to build one app. And I want you getting practice with that idea. So if you're using SQLite or just straight up file I/O, some students will want to do, or using an off-site database, none of that's cool. Unless you use an off-site database, which is the I always say the wrong one. I just saw it in chat. Maybe I hallucinated it. Or some students like to use an outside database. I do actually allow an outside database. Usually this is more relevant for your project than for the homework code, even though nobody's taken me up on this that I recall. But you do have to connect to that database in a separate container. I still want you building a system of containers that all form one app. So you can have a separate container that has your code that communicates to the outside database. I'm fine with that. But if you're doing any of these things, because students are always doing these things to try to do less work and learn less, most importantly to me. So if you're trying to learn less, then no. The answer is no. But most of that, I think the questions here are just getting confused by me patching loopholes. If you're just doing the regular stuff, you don't have to worry about it. Atlas, that's the one no, Atlas isn't the one I'm thinking of. I always forget. Could you repeat what you said about splitting on /r/n/r/n/n? Don't do it. Don't. That's what I said about splitting on /r/n/r/n. Don't. All right. So that's how we're going to handle our buffers. Keep reading until we've read content link number of bytes from the body. So for homework 2, your assumption, the first read, as long as you have 2048, I mean, if you do receive of 2, obviously you're not going to get all the headers. But if you do at least 2048, you can assume that you're getting all of the headers on the first read. You can assume that only one user will be uploading a file at the same time. This won't be true for homework 3. We will have to have concurrent users. Just by the nature of homework 3 being WebSockets, we want multiple connections simultaneously. I promise it's not too big of a deal to set up if you're using Python socket server, but to actually handle stuff gets a little more dicey. I already mentioned this. And we will check for this BS in your code. Part of the testing procedure is to manually check the code and make sure you're not doing something silly like this. If you just jack up your buffer, first of all, it shouldn't work. In some cases, maybe it won't. You might get away with it, you might not. But we're going to check it during grading. If you're doing this, it's just a fail on the objective. So don't do this. Specifically on application objective 1, don't do this. Especially wouldn't work in Chrome because you still have to read multiple times, but you'd be trying to read just twice instead of a whole mess of times. All right, so let's see some of this stuff somewhat in action. Again, I try to show limited code, and you all know that. Create a new window. I can trash this one. Oh, wait. I'm pretty sure that's where my Python thing is running. Well, let's just try to run this and see. I might just have to change the port. It's not that big of a deal. Python 3, server 2. Oh, we're good. All right. And I want to run this code that we saw last time. And I almost got to this demo before, but we weren't really armed to talk about it fully anyway, so we're going to get to it today. I want to go to my browser, refresh to make sure I'm hosting this thing, or actually I'm not hosting this thing. Again, I'm just opening the... No, I'm not. Sorry. Oh, no, I didn't want to do that. I just want to open the file. Oh my goodness, I can't even click the right thing. There we go. So I'm just opening the file. I don't want to do the front end because that's running on a different server that I'm not testing right now. But that is running, so now I know where Python's running. And it's using port 8080. I'm using 8000 right here, so we're all good on that. I want to close this one. So I have my server running. I have my HTML hard-coded to send requests to localhost 8000. So I don't actually have my server hosting this file. I explained this last time, but I think it's a cool thing to see now that you know a bit about web development. I just hard-code my front end, so my front end has nothing to do with my back end, which is something you very well can do, and it's something that hackers can do. They don't have to use your front end at all. They can just write anything that connects to your thing. I could change this action to google.com or buffalo.edu and start firing off posts and requests to whatever server I want to send them to. I can put whatever I want there. So I'm doing that just so I don't have my server hosting all the files of the server. Again, I don't want to show too much code in lecture. I will start showing more once we get a little deeper into the course, but I'm not ready for that yet. And I'm going to upload a file. Actually, I'm not going to upload a file. I'm just going to submit this and see what we get. So I get this user at port 55,380 is sending 1143 bytes of data. So when I submitted that form, I got the multi-part form stuff. I can see the boundaries. I can see the file is nothing. And there it is. And then the commenter is Jesse. I get my name in there. If I parse all this multi-part stuff, I can extract that value and get what I want. And I can see that I've read all this in one read. Let me explain the code too. I called receive. I'm printing out the bytes of data that were read, then printing out what was read, printing a new line to separate the requests, and then I'm doing this in a while true. Don't do while true on your code, unless you want to use a break statement. But the number of times I show this and then I just see while true and like this exact code in office hours and saying, why doesn't it work? It doesn't work because this isn't what you're supposed to do. This is just what I'm doing for a lecture example. But I want one TCP connection that's just going to keep reading from the TCP stream. For this connection, I read one time, I got all the data, and now I'm right back at this line and just sitting on this line. And when you call receive and there are no bytes to receive, it'll just hang. It'll just sit on this line and do nothing. If this returns 0 bytes, so I do have my check for 0 bytes here. If this returns 0 bytes, that means the client closed the connection. So if you do see 0 bytes, you can add a check like this just to be fail-safe with that. But if you see 0 bytes, it's safe to just go to the end of the thing. I can say if, I can actually change this. Why don't I? If, break. Oh, bring too much Java. So I can change it like that, because receiving 0 bytes from receive, that means client closed the connection, and we're ready to just move on with that TCP connection, because it's no good anymore. So right now it's sitting on this, waiting for more bytes, or it's infinitely looping and constantly getting 0 bytes because the connection's closed and just burning up my CPU. So let's send this another request. Let's send a file this time. I'm going to choose the smallest one, 11K. Submit. And let's see what we get this time. So this time we get a different port, so we have a different connection. This one probably is closed. The browser probably closed this by now, and that's just sitting in an infinite loop because I didn't restart the server. But this guy, 55474, this guy, it's my browser, but sent 831 bytes of data. If we look, yeah, even in Opera this time, actually, we got, kind of blows my Chromium comment out of the water, but we only got the headers. We know we just uploaded an 11K image, so we expect 11K plus headers of data, plus the overhead of all the multi-part form stuff. We expect quite a bit of bytes to be sent, probably about 12K. But the first read only gave us 831 bytes. We know we're getting a lot more than that. The first read was only 831 bytes. That's just the headers. So anybody's code who says, if the number of bytes read is less than 2048, then we obviously got the whole request. It's wrong. It's wrong even in the most simple example that I'm given here. 831 bytes. And then we go back to the top of our loop. Again, the server isn't doing anything. This isn't what your homework code is supposed to do. But I'm just going to go to the top of the loop. Now I get the full 2048. I can see my commenter, that part of the multi-part. I can see the headers for the image. I can see my blank line, and then the body of the image part, which is going to be all the bytes of the file. And I can see I get a bunch of bytes of the file. I get another 2048. We went back to the top of the loop, read another 2048, got a bunch more bytes. Another 2048, we got a bunch more bytes. Another 2048. Another 2048, a bunch of bytes, and then a 643. This is why people try to do that shortcut. Sometimes it will work if you get past the headers. 643 probably means I have the end of it, and there I can see my closing WebKit boundary. So I am at the end of the request at that point. So I would have to read quite a few times just to get that image in my code. What if I send an 8.2 megabyte image? First, I need to change my code to not print out all the data that was received. And I'm going to, actually, let me knock out both of those. Let's kill this server. I'll read some comments while I'm letting the port get, oh, nothing new, right? No, yeah. While I'm letting the port be released, we'll get port already in use. Well, not array. Why does it only read 831 on the first and not 2048? Because the browser only sent me 831. So when you call receive is going to give you up to 2048 bytes of data of the data that's available. The browser sent me 831, was that the number? 831. So receive said, whoa, I got some bytes for you. I got 831 bytes. That's less than your 2048, so here they all are. And then my code went on to the next line, and somewhere down here I'm starting to process things. Then the TCP socket from the browser starts getting the bytes of the body, but receive already returned, because it's not going to wait. It says, hey, you wanted data? I got some data right here. And then it gets more data after the fact. So the bytes of the body weren't ready the first time I called receive. So I only got the headers because that's all the browser sent at that point in time. So now, I already have, oh no, I lost it. So now we send an 8.2 megabyte image. Submit. We have to go to this socket a lot of times. I think, oh yeah, I'm at the top. A lot of times to be able to get all the bytes. I overflowed the buffer in my terminal. I can't even see all the times it printed out because I printed out so many characters that it started deleting my old characters in the terminal. But a lot of times you have to go here. So you don't use well true here, but you should use something like, well, I haven't read the content link number of bytes from the body. That's what your loop should look like, which is commonly a while loop. But well, I haven't read enough bytes, then it's up to you to figure out how to code that. I can't really say because it depends on how you set up your variables and everything, how you parsed your headers and all that. But this is the question you want to ask in your while loop. Have I read content link number of bytes from the body or not? I'm going to JavaScript. I'm doing it. So I have the same code. I'm going to print out, this person sent me this many bytes. I'm not going to print out the actual values of the bytes. Server 2. I'll get port already in use. Oh, am I not? Oh, they just released the port. So I'm going to do the same thing. Did that work? Hey, that worked. I'm going to do the same thing, but in JavaScript. Let me clean these. Let me just leave it. It's not that critical. But here, the big difference is we don't have control over the size of the buffer. We're getting up to 32K, it looks like, but sometimes it's 16K. Oh, here we didn't even get a full buffer. So it's probably trying to give me bytes as fast as they're coming in. And it's giving me them in big chunks, but it's a big variety of values that we're reading. So if you are using JavaScript, for sure you can't do any of the cheese. You just got to read content length and keep reading until you get that many bytes. But we can see the buffer is much bigger in JavaScript by default. Some of these were, there's a 65K even. But we have no control over the buffer size. I mean, it's possible. Maybe there's some configuration that you can change. But by default, you don't have control over the buffer size. It's just whatever JavaScript decides, whatever the library decides is appropriate for whatever situation is happening. Last one was a little more than 16K, it looks like. Actually, it didn't take long at all. But JavaScript, this callback will be called each time. So I don't have my while true here because this is an event-based architecture. This function just gets called whenever there's data to be read. And behind the scenes, the library is doing the buffering side of reading however many bytes it's going to read. While true equals false. Yes. Yeah, so that while true needs to be replaced with checking the content length. So we're supposed to read all the body length, but we read it in chunks. Does this? I mean, you don't have to use 2048, but don't use something like megabytes. If you use megabytes, we're going to test with tens of megabytes. Like we're going to overflow your buffer for sure. So you have to write generic code that reads content length number of bytes, no matter what your buffer size is.